Alright, so we're asked to do these three problems on composite functions. It says fog, but you can rewrite it as the f is on the outside and the inside is g of x. Yesterday we learned to kind of work from right to left. So start over here and work this way. So g of x, we're going to put basically g of x into our function of f. So in my function of f, here is g of x. We're going to put that into that function. So let's write that. X squared minus 2. Remember, that kind of looks funny because normally you would put in every x value just x. But instead of every x value, we're going to be putting in x squared minus 2. So here is the original problem. F of x equals x plus 1. Class, now instead of putting x there, we're going to write what? X squared. So this reads f of x squared minus 2 equals, remember your substitutions are in parentheses, those are important, x squared minus 2, and then you have this plus 1. Class, do I need the parentheses with that math operation? No, you can just drop it, right? And then you just combine like terms. So our answer is x squared minus 1. Raise your hand if you got that. Good job, you. Alright, let's try the second one. This one says f of x, we're going to put into our function of g of x. So g, and then in the function, we're going to put in f of x. Let's use yellow. So here, I'm going to put in now, my f of x is x plus 1. And now I'm just going to write my g function. My g function is equal to x squared minus 2. And instead of writing x, we're going to put what in here? X plus 1. So now I have g of x plus 1 equals x plus 1 squared, right? Because that's not part of the x, minus 2. Class, is this going to be x squared plus 1? No. This here, you're going to do your FOIL, or your box. I like to do a box. So this is really x plus 1 times quantity x plus 1. There's two sets of parentheses. Does that make sense? That's what an x1 tells you. So we're just going to multiply. X times x is? X times 1? X times 1? 1 times 1. So if I combine like terms here, I get x squared. Add those together, you get 2x plus 1. And don't forget that minus 2. That's a common mistake, is to forget that. And we just finished this up. I have x squared plus 2x minus 1. And that's our answer. Raise your hand if you got that one. A little bit more algebraic work, right? And let's do the last one. I'm going to rewrite this. It says h of f. So h is on the outside. F of x is on the inside. F of x is our color yellow. So basically, instead of writing, I'm going to have x plus 1 here for my function of h. h is this one up here. So I have h of x equals x squared plus 3x minus 4. Right? This is my what I just got from up here, right? And every x value now we're going to put in what? Uh-oh, we've got a lot of work to do, don't we? This one has a lot of algebraic work to do. So every h value I'm putting in x plus 1. X plus 1. Remember, every x value now is x plus 1, but squared, plus 3 times x plus 1 minus 4. We already did x plus 1 squared from above, right? What does that become? X squared plus 2x plus 1. Distribute here. What do you get? 3x plus 3. And don't forget that minus 4. And then all we have to do is just combine like terms. Any other x squareds? So x squared, 2x, 3x gives us what? 5x. And then the 1, 3, and negative 4 equals 0. So our answer is x squared plus 5x. So in doing these problems, as you saw me work through those, I would write them like this. It kind of tells me, instead of writing f of x, every x value, I'm going to put in g of x. Okay?